Hello, it's me again. Today we're going to talk about solving nonlinear systems. So last week you reviewed how to solve a system of two lines, and that could have been no solution if they were parallel. It could have been infinitely many if it was the same line, or you just had one solution where the two lines intersected. So that was a review from Math 1, and of course in Math 2 we step it up a notch, and so we're going to talk about what happens if you have a system of equations and they're nonlinear. In other words, you have a parabola maybe, a quadratic equation, which is a parabola, and a line, for example. So this could possibly have two intersections. You could have one intersection, or you could have no intersection. And so we're going to talk about today how we can solve a quadratic with a linear. We could have two quadratics. I mean, it could be a possibility of anything here. So I could have two quadratics and they could have two intersections. They could have one, they could have none, they could have four. It just depends on what you're given. We'll even talk about circles and lines. Those can have two intersections. We can talk about parabolas and circles. I mean, you could take anything, any kind of function or circle or hyperbola, any picture, and you can intersect them, or maybe they don't intersect. So today we're going to talk about how can we figure out these solutions. So the way that we solve these is you use substitution, just like you did with the linear ones, or elimination. It just depends on how they're lined up, if substitution would work best or if elimination. And you know if it's substitution because you'll have an equation that's in y equals form or in x equals form, and you would take what that equals and shove it into the other equation. Elimination works best when they're lined up, maybe both in standard form, and so then you can find opposites and cross them out. If you don't have opposites, that's where you can multiply one or both equations to make opposites. All right, so I'm going to show you a few examples, and then at the end of this video you will have two problems to try on your own, and then you will write those down, solve them, screenshot it, and email me those two problems. All right, so this first example, we've got x plus y equals 1. That's a linear equation because I can solve it for y and get y equals mx plus b. And my second equation is y equals x squared minus 5. That's a quadratic, see the x squared? So what I have is a parabola that opens up because a is positive, we talked about that. And I have a line. I don't know where it intersects at, and actually my line's a negative slope. I just drew a line, oops. So it could have two solutions, it could have one, it could have none. So we're going to determine what the solutions are. So if you notice in both of these equations, they're not lined up, so I'm not going to use elimination. But I do see the equation that's got the x squared minus 5, so that's y equals. So I can take this portion of that equation and I will replace the y in the top equation. So I'm just going to box up what y equals, and I'm going to scratch this y out as a reminder that that is going to go in there. So my new equation is x plus, you can put parentheses around it. It's a good idea if you have to distribute. In this problem you don't. And then if you notice, I have an x squared and an x in this equation. So we know how to solve quadratic equations. You have to set them equal to 0, factor if possible, or use the quadratic formula if it's not factorable, and then solve. And I believe that this one is definitely factorable. Just looking at it, I can assume. So I'm going to rearrange this, and I'm going to move that 1 over. So x squared would come first, then my x, and then negative 5. When I move this 1 over, I'm going to subtract it. So negative 5 and a negative 1 is a negative 6. So all I did was put it in standard form by moving that x squared first, then the x termed, and then my constants I put together, negative 1 and negative 5. So now I'm able to factor this, so I'm going to set up my two houses, and I'm going to ask myself what times what gives me 6. And those same two numbers have to be able to add to give me a positive 1. So if you think about 6, you got 6 times 1, that's not going to work. 2 times 3 will work. It needs to be a positive 1. So a positive 3 and a negative 2 would multiply to give me my negative 6, and it adds to give me my positive 1. No leading coefficient, so I'm done factoring. Split and solve, so x equals +2 and x equals -3. Okay, you guys have already practiced and solved quadratics by factoring, so that should be easy peasy. The next thing you're going to do is, I need to figure out these, obviously I have 2 points, so I need to figure out what these 2 ordered pairs are. I know the first one is 2 for my x, but I gotta figure out what that y value is. The second ordered pair is a -3, I have to figure out what that y coordinate is. So what you're gonna do is you're gonna take these answers and plug it into either equation from the beginning. I usually like to pick the one that's the x or y equals. Seems easier. All you gotta do is plug in and solve. So 2 squared is 4. 4 minus 5 is -1. Plug in -3. Be careful here. -3 squared is +9. 9 take away 5 is 4. So those are my 2 solutions. Pretty simple. I'm going to show you another example. I think I have a total of, that's another substitution one. I think I'm just gonna do, yeah, I'll do all 3. So example number 2 is x squared plus y squared equals 9, and that is a circle. Let me slide that up so you can see it. That is a circle if I were to graph it with a radius of 3. Y equals x plus 3, and a line. So I have a circle and I have a line, and maybe they have 2 points of intersection, maybe they have 1, maybe they have none. I'm not sure, but I can solve it to determine how many solutions. Okay, so in this equation, they're not lined up, so elimination would not be the way to work this problem out. Instead, you see the y equals, so I'm going to box this up. Because it's a y, I scratch out just the y, not the y squared, but just the y. So when I create my new equation, I get the x squared plus, put this in parentheses. There's my y, but I remember I had that squared on the outside, so I gotta keep that squared. Equals 9. All right, so to solve this equation, we need to FOIL. So when I FOIL this, I get x plus 3 times x plus 3. X times x is x squared, x times 3 is 3x, come back, 3x, and 9. Combine your like terms, so this is x squared plus 6x plus 9 equals 9. Okay, so make sure you remember how to FOIL. We can do the box method. So I have gotten x plus 3 squared to be x squared plus 6x plus 9. All right, so now I'm ready to solve. I need to set it equal to 0. And then factor it if it's possible. X squared plus x squared is 2x squared plus 6x. I'm gonna move this 9 over and they're gonna cancel each other out because a 9 take away 9 is a 0. And I can factor this as a binomial. To factor a binomial, we're gonna look for the greatest common factor. The greatest common factor is 2x. So when I divide by 2x, I get x. Divide by 2x, I get 3. And now I'm ready to split and solve, set both sides equal to 0. So when I divide by 2, I get x equals 0. When I subtract 3, I get x equals -3. All I did was solve that equation. Now if you remember from the previous problem, after you've done this, you're not done. This just gives me the x coordinate for one of my points, and this is the x coordinate for the second point. So it must look like this. So when I plug in, I get 0 plus 3 is 3. When I plug in my -3, I get -3 plus 3 is 0. So those are my 2 solutions for my circle and my line. Pretty cool. Okay, I have one more example because if you've noticed, we've done 2 that use substitution. We haven't touched elimination yet. So guess what? This next one will be elimination. So example number 3, let me show you one with elimination. This is an x squared plus 2y squared equals 11. And then we have a 3x squared minus 2y squared equals 25. This is like an ellipse and a hyperbola. That's what it looks like if you were to graph it. All right, so if you take a look, they are lined up. They're in what's called standard form. And so we want to see if I have any opposites. So if you look right away, you see the 2 and the -2. Those are called opposites, so I am going to eliminate by adding. Because if I add 2 with a -2, they cancel out. So I get 1x squared plus 3x squared is 4x squared. That's canceled, so I'm ready for my equal sign. 11 plus 25 is 36. All right, to solve this equation, we can set it equal to 0 and then factor it, or we can just find out what x is by solving for x by dividing by 4. So x squared equals 9. To get rid of a squared, you take the square root, and we know that the square root of 9 is 3. However, because we're dealing with solving systems, we need to put the plus and the minus sign. We want the positive or the negative because we know that negative 3 squared is 9 and positive 3 squared is 9. So we need to take both positive and negative values here. So this tells me I've got 3 comma something and I have negative 3 comma something. But if you look in the picture, it looks like we're going to have 4 solutions, and I'm going to show you why that is in just a second. Take your answer and plug it into either original equation. I'm going to go to this top one, and I'm going to plug in 3 first. So take these and plug it into that top equation in for x. So I've got 3 squared plus 2y squared equals 11. That gives me a 9 plus 2y squared equals 11. And if I go too fast, you can always pause and rewind and go back if you need to. I'm going to subtract my 9, so I get 2y squared equals 2. Divide by 2. Take the square root. This gives me a plus and a minus 1. Remember, whenever you take the square root, you want to take the positive and the negative. So this tells me when I plugged in a 3, I got a positive 1 and a negative 1. So check that out. That gave me my 3rd point there. All right, so I'm going to do the same thing when I plug in my negative 3. Well, if I plug in a negative 3 and I square it, don't I get the same thing? 9, subtract 9, everything's going to be the same. So I got a positive 1 and a negative 1 again. So this will create my 4 answers. Isn't that nifty? And like I said, if I went too fast, you can pause, rewind, go back and rewatch. Not like you can in class. So that's a pretty cool feature of the video. Okay, so just remember, if you take the square root of a number, you must use the plus and the minus answer because that's going to end up creating those multiple answers. When you plug in, make sure you put parentheses around your negative numbers when you're squaring. Super duper important. All right, so I have 2 problems that I want you to do. You're going to work these problems out and you're going to email them to me. And then I will let you know if they're right or wrong, and I'll look for some mistakes if you have any. All right, so the first one is y equals x plus 3. And then I have x, y equals negative 2. So solve that one, figure out the method you want to use. The second one is 2x squared plus 3y squared equals 30. 3x squared minus 2y squared equals 19. Now if you notice in this one there's no opposites, you're going to have to make opposites. And to make opposites, your hint is you're going to have to multiply. Okay, so you may have to multiply the top by 3 and the bottom by 2, or vice versa if you want to use 6 for your x's and 6's for your y's. Figure out something that you want to eliminate. I would probably multiply the top by 3 and the bottom by 2, because that would make this opposites. They would be opposite 6's. But that's my hint, multiply. All right, so do those and email them to me. And I have a second assignment I want you to do, and it's going to still work with non-linear systems, except I'm going to have you do it on Desmos. So I'm going to give you a few problems, and you're going to work the problems out on Desmos. So the second video you'll watch deals with how to solve systems using the computer. But these 2 problems, you have to show your work and send them to me. You can definitely check your answer using Desmos, but you must show your work. All right, thank you.